Hello, I'm Michael Socavetta. In this video, I'm going to show how to significantly improve the speed of JavaScript functions using two slightly advanced concepts, closure and memoize. First, I'm going to create a sample function, I'll call it marketing report, with a parameter called ads, then an array called new customers. I'm going to create a for loop that represents visitors that came to the website from the ad campaign. But the purpose of this calculation is only to take a lot of time. It's not a real business calculation. We'll console log how many pretend new customers we get within 10 ad campaigns. "100 new customers. Great. I'll set up console time to see how long the function took. 23.5 milliseconds. Now I'm going to improve that time by creating a closure. A closure is the ability of a function to access variables and functions that are lexically out of its scope. As soon as that function is created, the closure is made. So I'm going to copy the first function and within it return an anonymous function and add our parameter to it. I'll move the console log inside that function, but we really don't need it. Lastly, I'm going to call our withClosure function and pass it to fast function that I'll use with our original argument of 10 ad campaigns. I'll modify console time so we can identify the two results. Save and look. Our new closure function ran in 0.03 milliseconds, a drastic improvement in speed. The reason that works is memory in JavaScript. Closures use the heap instead of the short-lived stack. All right, let's clear that and do another example using memoize. I'll create a new function using function expression as opposed to the function declaration I used in the first example, and it will be an arrow function with three parameters, parts, products, and orders. I'm going to have another for loop to increment the number of orders and multiply the number of parts we need by the number of products we've sold. Again, this is a calculation just to do something that takes a lot of time. I'll console log my function with arguments that are fairly large, as you can see here, including 10 million orders. Again, I'll add console time to track its speed. Now this example is to show what happens when a process needs to be repeated with the same argument. So here I'll show it running 3 times. Each is about the same, but I can improve on that. I'm going to create a new function declaration, not function expression. A function declaration be hoisted if need be. This will take 2 parameters. Then I'll initialize an object, create an anonymous function with a REST operator to take in arguments, not to be confused with a spread operator, and turn them into an array that we can parse into a JSON object, and use an if statement to check if it does not have results. The way this logical OR operator works, the 2 pipes here, is that it will evaluate the condition of context, and if it's falsy, then it moves on to this and the REST argument. Finally, return the results and take the original function product count, put it in as an argument for memoize, and pass that to memoize product count, which I'll use to output 3 times as before. Now let's take a look at the second and third calls of the memoized batch here in green. See how the time is drastically improved? After the first call, it took the arguments and cached them. That's how memoizing works. Simple, yet effective. I hope this has helped.